Hi everybody, this is Mrs. Ellsworth. And so if you were gone on Monday, I would have instructed you on what did you miss if you came in during lunch or whatever. And so I would have instructed you on what you missed, and some of you guys were gone for baseball. So here is what you missed. Okay, the first group, Rosie's group, with Riley and Jesse, they went and showed us how to name and draw halocarbons. So the functional group is just an X. Okay, and so it would be on any kind of carbon chain, this X, and it represents a halogen. So let's learn how to name these. And so they were so nice to give us this example right here. And so this is an ethane, right? 2-carbon chain is ethane, but it's got this chlorine on it. And so it's abbreviated as a chloro, and so this would be called chloroethane. Pretty nice. Okay, here's another one. Okay, and so this right here has got a fluorine on it, and so it is also known as a butane, and so this one we have to tell what number is on because it's not on number 1, so this would be on 2-fluorobutane. Okay, let's go backwards from that. From the names, come up with draw it. Okay, so then here's chloropentane. So 5-carbon chain, chloro is located on the first one because we don't want to have to put a number on it, so it's always located on the first one, either here or there, right? And here's a pentane, a 5-carbon chain that is located on. Okay, now try this one on your own. Pause it. Okay, this is 2-bromopropane, and so that means you've got a propane, which is a 3-carbon chain, and it has got the bromine located on number 2, and so this is how you would draw that one. Okay, the aldehydes was Blake, Ty, and Mackenzie that went and showed us how to do this. And so this is pretty nice. These ones are the functional groups. It's got a C double bond O, and it's got an H on it. And so here's what it would look like. You just put an R in the front of that.
Stop into your...
Sorry. Okay, anyway, so here is our R group here. Notice that we include the C double bond O. We include that C in here, so it's 3 carbon total, and so this would be called propanal. Notice that that's just 1 letter off of alcohol, which would be propanol. And yeah, I know what the ending looks like, but it's propanal. Okay, and so that's just that nice. You just name them just like that. You got that carboxyl group with the hydrogen on there, and so that tells you what it is. Okay, so then this one would be called butanal. Okay, so there's 4 of them for a but, and then here's an H and the double bond O. Octanal. Okay, how would you do that one? You would go and write out 4 carbons. Excuse me, 8 carbons. The last one needs that C double bond O and an H there. Okay, then decanal is the next one, decanal. So how would you do that one? Stop a second and figure that out. Okay, so this would have to have 10 carbons, including this carboxyl group, that carbon, and so then it would be C double bond O and H. Okay, the next group, they're going to show us their stuff on Tuesday, so hang on. Ketones. Ketones is the same exact thing as an aldehyde, except for we've got the C double bond O, and it's located in the middle of the chain instead of at the end of the chain. So in this case right here, it could be an R prime right there, an R prime or an R. So this represents C double bond O, by the way, and it could be in the middle of the chain. It could be on the side, on the edge of the chain, but not at the very, very end of it. Okay, so these ones are all really pretty ones that are all symmetrical. But let's go and figure out how we would name this. Notice it's got 1, 2, 3, 4, 5. So this would be a pent. And then you've got to put an anione on it. So it's kind of like ketone, but the an is because all single bonds, so this would be 3-pentanione. Okay, because there's 5 pent. It's located on carbon number 1, 2, 3. The aldehydes would be on the very end of it, wouldn't it? So these two are really closely related about that. Okay, how would you name this one? It's got 1, 2, 3 carbons, so it'd be a propanone. And so it'd be located on number 2, so it'd be 2-propanone. All ketones have numbers in the front of them. Okay, draw this one. Quiz yourself. Do that. Stop. Okay, so this has got to have 9 carbons on there, and then carbon number 5, you've got a carboxyl group there. That's it right there. Okay, the next one is 4-heptanone. Okay, and 4-heptanone, that has got, hept means 7, so it's a 7-carbon chain, but on the 4th one you've got that carboxyl group. Pretty nice. Okay, ethers, we had them also shown on Monday how to do them. Notice that there's an O in the middle of the group. You could have a longer one on one side, or they could be the same size. Okay, notice that this O right here has got 2 branches on it. Okay, so for the common name, this would be called, the shorter name is always named first, so it'd be ethyl, propyl, because it's 3 carbons, propyl, and then ether. Okay, and so, but IUPAC naming is how we're supposed to name it, but not all of them are like that inside the catalogs when we order them. So this would be eth oxy propane. It's actually easier, but this old-fashioned naming is still just caught so strong that people still follow that. Okay, next, let's look at this one. Okay, shortest one is named first, so that's going to be a meth. And then here's an eth. Okay, so what's the common name for that? Methyl, ethyl, ether. What would be the IUPAC naming for that? Meth, oxy, ethane. Okay, so here's the common name. Okay, and so draw that, methyl pentyl ether. Okay, methyl's got 1 carbon on it. Pentyl has 5. Okay, and then of course you notice that oxygen can only make 2 bonds on all of these. Even when you got a carboxyl group with a double bond O, you can only get 2 bonds on an O. Anyway, so this one's methyl, pentyl, ether. What would be the IUPAC name for that? Oops, it would be meth, oxy, pentane. Okay, here's another one. It is eth-oxyethane. So you've got an ethyl group here and an ethyl group here. Okay, and so that's how you would draw that one. But I like how they've got this here. So if you were going to name this as the common name, it would be ethyl-ethyl ether. And they don't do that, so it would be diethyl ether. Okay, so that's how you do the ethers. You've got to know both ways of naming those. Okay, okay, and esters is coming up on Tuesday. Okay, carboxylic acid groups. Okay, so in this right here, Faith, Lydia, and Delaney, they went and told us about the functional group. Okay, and it's a C double bond O and then OH. Now the aldehydes had an H here instead of an OH. Okay, and so these will always be on the very end too. Okay, how to draw it. So with butanoic acid, but is going to be a 4-carbon chain, and then you put this right on the end of it. Make sure that you're including this as the 4th one. 1, 2, 3, 4. So that's going to be how you do butanoic acid. Notice that the ends of these, anoic acid. Okay, pentanoic acid. Okay, so you're going to have 5 carbons all together with this functional group right there. So 1, 2, 3, 4, 5. And so that right there is pentanoic acid. Over here, how do you name them? 1, 2. So it's going to be ethanoic acid. 1, 2, 3. Propanoic acid. Okay, I think that's about it. Yep, that's as far as we got. And so the esters and the amines, they're coming up right away next time we meet. So there's a way for you to be caught up on your homework there. Okay? I'll see you later.